Hello, everyone. So today we're going to be discussing what is FAIRmaterials. Before we delve into the FAIRmaterials package, it is important to discuss where current ontology tools fall short. Protege is currently the most widely used tool for ontology creation. However, there is a steep learning curve for terms used in Protege and for its overall functionality. And this complexity prevents some researchers from creating ontologies entirely. And this is where the FAIRmaterials package comes in. The FAIRmaterials package addresses these issues while providing all of the essential Protege functionalities. The package is based on an easy-to-use CSV template with descriptions for all of the information a user fills out, one of the sheets of which you can see at the bottom of the slide. And the FAIRmaterials package provides additional outputs for ontology visualization and documentation. Our package is based on the RDF-lib library. RDF-lib is a library for working with RDF that contains tools for parsing and serializing into many ontology syntaxes, for documenting the ontology with a tool called payload, and for validating the logical consistency of any RDF graphs that are turned into an RDF-lib graph object. And the bottom line is that RDF-lib allows us to programmatically create an ontology for experimental data. So to break down the package, which is bilingual because it is available in both Python and R, parses the CSV sheet and populates an RDF-lib graph with the input data. It then serializes the RDF-lib graph into an OWL and JSON LD format, which are two of the outputs. It generates a visual of the ontology schema, and it outputs an HTML file containing documentation for the ontology in the Python version only. So why is the ontology visualization useful? The ontology visualization output allows for users to immediately visualize the OWL file and to ensure that it's correct. The output includes all of the ontology terms, relationships, value types, and units. And as opposed to WebVal or other ontology visualization tools, the output image is static, which means that it is easily shareable and embeddable within documents. Another output of the package is an OWL file. An OWL file is the standard knowledge representation language for ontologies because it is easy to read for both humans and machines, and all OWL terms are explicitly defined and standardized, which means that there's no need for specialized translators. The package also outputs a JSON LD file. JSON LD is the W3C standard for linked data, meaning that it is a universal way to read, publish, and reuse data. It is easily combined with other linked data to form new knowledge, and it is self-documenting. The package JSON LD files consist of a context section at the top, which defines and provides prefixes for URIs to ensure that the main body of the JSON LD file is more easily readable for humans. The package JSON LD files also automatically add an empty alt label section for defining synonyms or alternative names for every term in the JSON LD file. The final output of the package, which is available in the Python package, is payload functionality. So the package outputs a payload HTML documentation file, which is a huge step towards findability and human readability. This documentation page outlines all of the ontology classes, all of the object properties, and all of the data properties. Another core functionality of the package is that it is able to export or to import external ontology information into the ontology. So when users create ontologies that use external ontologies, certain information must be imported into the new ontology, including all labels, definitions, and descriptions. With our package, all of these are automatically imported into the RDF-lib graph, which then gets serialized and outputted to the user in an OWL and a JSON LD file. The final core functionality of the package is that it is able to merge ontologies together, and it has fully functioning merging of ontologies with warnings for users defining terms multiple times across different ontologies. So let's say you have two ontologies, XRD tool and XRD recipe, with the same label measurements. The package will throw a warning saying that there is already an existing RDF triple with the same ontology label measurements in case the user wants to assign one of the terms another label. There is also no limit on how many ontologies can be merged in one execution of the package, provided that the user fills out all of the CSV sheets and puts them into the same folder. Thank you.